Hi, my name is Kyle Clonan. I'll be speaking to you today about the downstream transport of cyanobacteria in a drinking water basin in New Jersey. I was part of this collaborative project between the New Jersey Water Supply Authority, Montclair State University, USGS, and the NJDEP. I was able to wear two hats in this, working as an employee for the New Jersey Water Supply Authority while also pursuing my master's degree at Montclair State University. I'm disappointed I won't be able to come in person today, but I'm thankful that my advisor, Dr. Wu, will be here to answer any questions and fill in any additional information. Cyanobacteria caused harmful algal blooms, or HABs, are proliferating in frequency and intensity across the state of New Jersey, causing concern for recreation as well as drinking water managers. Most research thus far is focused on HABs in lakes and reservoir settings, while there is a lack of literature focused on the transport of cyanobacteria and their associated toxins after they are discharged from lakes and reservoirs. This is especially important in systems with downstream drinking water intakes. One example system is the Raritan Basin water supply complex in New Jersey, where upstream reservoirs such as the Spruce Run Reservoir and the Round Valley Reservoir feed downstream drinking water intakes in the lower Raritan River, which together serve 1.5 million people. The Raritan Basin water supply complex has 3 upstream lakes with persistent HABs. These include Bud Lake, which begins the south branch of the Raritan River. Then there is Spruce Run Reservoir and Rosedale Lake, which is the upstream point in the Stony Brook Millstone sub-watershed of the Raritan River. All in all, going through the rest of the presentation today, we've named our sites from RR1 to RR5, which are sites traveling along the main stem Raritan River. And then MR1 and MR2 are 2 sites in the Stony Brook Millstone River subwatershed. All in all, we have about 30 river miles between MR1 and RR5, and about 60 river miles from RR1 to RR5. Down here, our last point, RR5, is the beginning of several drinking water intakes which serve upwards of 1.5 million people in central New Jersey. So our objectives in this study were to review the persistence of cyanobacteria traveling from these upstream persistent HAB water bodies to the downstream drinking water intakes, and then look at which water quality and physiological parameters may influence the persistence of cyanobacteria traveling downstream. 8 sites were sampled over the course of a year from August 2020 to August 2021. They were sampled 2 times a month during the spring, summer, and fall growing season, and once a month during the winter for a total of 20 sampling events. While no time of travel study has been conducted on the region, they were sampled from upstream to downstream order and spread over 2 days to estimate the flow of water. These sites overlapped with existing USGS surface water monitoring stations outfitted with continuous discharge sensors. And the schematic here shows the spatial distribution of flow through the region and river miles between sites. RR1 to RR5 follows water from its origin at Bud Lake to the drinking water intakes down near RR5 and is joined by the Spruce Run Reservoir and Spruce Run Outlet midway through. Meanwhile, the Stony Brook Millstone Complex is abbreviated with the MR1 and MR2 sites, and they join the Raritan River just above our final site, RR5, which is situated near the beginning of several drinking water intakes. There are several impoundments throughout the region, mostly low-flow dams. There is also a run-of-the-river reservoir called Carnegie Lake, midway between MR1 and MR2, and a drinking water canal that was not sampled but continuously discharges at various gates into the Millstone River, running parallel from it for about 20 miles from midway between MR1 and MR2 to RR5. My thesis was part of a much larger study which collected many more parameters, including toxins and various continuous monitoring data that I did not touch on. The factors I'm focusing on today and that I reviewed include general physiochemical parameters from a YSI, including dissolved oxygen, specific conductance, pH, and water temperature, various water nutrients, which include orthophosphate, total phosphorus, nitrate plus nitrite, ammonia, and total nitrogen, which were all unfiltered samples run by the NJDEP. While phytoplankton community assemblages, chlorophyll A, and turbidity was conducted by the lab at Montclair State University's New Jersey Center for Water Science and Technology. And we make use of the USGS continuous discharge parameters situated at each station. Before getting into results, I'd like to outline our data review methods. Following Jennifer Graham of USGS's 2012 study, looking at the downstream transport of cyanobacteria in the Kansas River Basin, I'll review differences in total cyanobacteria abundance versus expected abundance due to dilution between sites. This is really a method of looking at downstream recovery of cyanobacteria cells between their lake or reservoir outlet origins to each downstream site. I'll also review the relative composition of genera and dominant taxa at each site. This review helps show if certain genera survive loadic transport better than others, or could act as source-specific signatures, marking the influence of an upstream source on downstream sites. And review correlations between total cyanobacteria recovery rates and the physical and chemical parameters we looked at during this study, broken down by the Raritan main stem site group and the Millstone River subwatershed. The first column, common genera, show genera that were observed in over 50% of the site's 20 samples. One thing we immediately see is that the direct outlet sites were the only ones to frequently feature filamentous genera such as Dolichospermum and featured much more diversity overall, as indicated by their median genera richness values of 7 or 8 per sample. Otherwise, most flowing river sites only held 2 to 3 genera, as most genera fell out of samples as the water faced downstream pressures. This consistently left Aphanocapsa, Synechococcus, and Crucococcus in the downstream samples. The lake outlet sites also featured the highest cyanobacteria cell abundances, as illustrated by typical counts of 250,000 cells per milliliter at RR1, which is Bud Lake's outlet site, and nearly 34,000 cells per milliliter at the Spruce Run outlet site. Average cyanobacteria recovery rate, which was calculated by dividing the measured cyanobacteria cell count at each site by the expected amount due to dilution from the headwater sites, decreased as we went further downstream, but in the Raritan River received a considerable bump after absorbing Spruce Run outlet's flow. This indicates that the cyanobacteria community reaching the drinking water intakes near RR5 was much likely more influenced by the Spruce Run reservoir than Bud Lake. In the Millstone River, we see recovery rate actually increase over 10 times between MR1 and MR2. This indicates that there is likely growth between sites or a significant input from an unsampled source entering the Millstone River between MR1 and MR2. Looking at these two plots, which show total phosphorus on the left and total nitrogen on the right, two groups emerge in each plot. The direct outlet sites of RR1 and SRO each regularly had the lowest available phosphorus and nitrogen concentrations, but the highest total cyanobacteria abundances, while the remaining river sites regularly had higher nutrient concentrations but lower overall cyanobacteria abundances. This was not only true for total phosphorus and total nitrogen, but very similar in plots for orthophosphate, ammonia, and nitrate plus nitrite as well. This illustrates that cyanobacteria abundance at the nearly stagnant late outlet sites are likely nutrient limited, as these low velocity sites act very similar to lakes and reservoir phytoplankton communities, while abundance at downstream river sites are more likely limited by another factor. However, after conducting correlation tests, there were no significant correlations in the Raritan River main stem sites between downstream cyanobacteria recovery rate and total nitrogen or total phosphorus. While I don't have time to show plots for all parameters, the one thing that did positively correlate with cyanobacteria recovery rate in the Raritan main stem was discharge level. We see that there is a significant positive correlation between the discharge level and cyanobacteria recovery rate in the Raritan River main stem. We had different results between sites in the Millstone River subwatershed. As a previous slide had shown, recovery rates were well over 100% in the Millstone River, indicating either algal growth or inputs from unsampled sources between sites. Here, we see a significant positive correlation between cyanobacteria cell recovery rate and both total nitrogen and total phosphorus concentrations. Meanwhile, while it is not statistically significant, if anything, there is a negative correlation between discharge level and cyanobacteria recovery between sites in the Millstone River. None of the other parameters analyzed during the study, such as temperature, pH, dissolved oxygen, or turbidity, displayed other meaningful correlations with cyanobacteria recovery rate. Water temperatures were typically within the 18 to 25 degrees Celsius range optimal for phytoplankton growth from August to September 2020, as well as from mid-May through August 2021. Mean site pH ranged from 7.12 to 8.3, while mean dissolved oxygen ranged from 7.42 to 11.6 milligrams per liter, all within levels to support healthy phytoplankton growth production. The published literature consistently cites discharge as the primary factor governing lotic phytoplankton production, composition, and abundance. Discharge can affect riverine phytoplankton assemblages in two ways. Low discharge levels, such as during a drought, allow for the pooling and simulation of lake-like conditions. This allows for cyanobacteria to take advantage of available nutrient concentrations and sunlight and grow in-river. We believe this is what is happening in the Millstone River, as indicated by the positive correlation between recovery rate and nitrogen and phosphorus availability. This was further evidenced by a bloom in the Millstone River during drought conditions in 2021 after this study was concluded. Meanwhile, the cyanobacteria exiting lake communities have significant influence on phytoplankton communities found downstream. Without opportunities to grow inside the river, existing literature states that most river phytoplankton can be tied to upstream origins. Other studies have found increases in stream velocity and discharge to shorten travel time and increase the downstream transport of phytoplankton from these upstream lake sources to downstream sites. We believe this is what is occurring in the Raritan River, where we found a significant correlation between cyanobacteria recovery rate and discharge levels. This study found cyanobacteria persistence downstream was influenced primarily by discharge in the Raritan River, with periods of higher discharge resulting in greater persistence of cyanobacteria traveling from the Spruce Run Reservoir to downstream drinking water intakes in the Raritan River. Meanwhile, the Millstone River was mostly influenced by nutrient availability, showing the ability to bloom during periods of low flow. The Millstone River may have more influence on algal composition at these drinking water intakes during periods of low discharge. If trying to assess risk for cyanobacteria blooms in their own raw water, drinking water managers should investigate their subwatersheds separately, as they may show different vulnerabilities to different environmental conditions. Thank you again so much for your interest in my presentation. While I'm disappointed I can't be there in person, I'm happy that my advisor, Dr. Wu, is there and she can answer any questions you may have on the study. Also, we are both available through email if you are viewing this online and would like to contact either of us directly. Thanks again and have a great day.